Hello, hello! Today we're going to be going over multiplying and dividing rational expressions. And this is level 1, meaning the more basic of it. So I'll make a few more videos with these problems getting a little harder. Okay, so when we multiply rational expressions, what we have to do is factor the top and bottom of each fraction, if possible, of course. And then we're doing the same thing as in simplifying rational expressions. We're crossing things off from top and bottom. The awesome thing in multiplying is that they don't have to be on the same fraction. So let's take a look. Now, when I look at this first problem, I notice that there is nothing to factor. So I'm going to start reducing right away. The first thing that jumps into my eyes is this x plus 2, top and bottom. Different fraction, sure, but one's on top, one's on the bottom, so we're good to go. Next, we have an x minus 2, one on top, one on bottom. Great. There is one more thing that I can reduce, and I'm going to write that on the side so you can see where it's coming from. I have a 3 on the top and a 9 on the bottom, and that can be reduced to 1/3. So I'm going to cross off the 9 and write a 3, cross off the 3 and write a 1. Okay, that's pretty much it. Since we are done crossing things off, we're going to multiply straight across. So let's see what our answer is. On top, all I have left is a 1, so there's the 1. And on the bottom, I have a 3 and an x plus 4. It's just more traditional to write our monomial in front of our binomials. That's why the 3 is out front, even though you did see it come second in the problem. So there's our answer. Let's try another one that we actually have to factor, like this. Okay. Ooh, okay, so this top one here, let's see, is there a greatest common factor? No. Boo. Okay. So then let's factor it, and I'm going to use the product sum, the AC method. So I'll just remind you of it a little bit. We want to find two numbers that multiply to a times c, so negative 42, add up to positive 1. So that would be 7 and, whoops, that 6 just doesn't want to be written. Geez, let's try that again. And negative 6, it doesn't like me. What's going on? One more time. Last time. There we go. Phew. Let's go over this factoring. I didn't do it in that last video, so let's go over it this time. Okay, so what I'm going to do is, I like calling this the AC method because we keep the A and the C, not just the product sum method. And then I'm going to write plus 7x minus 6x. Let's split it down the middle. On this side, I can factor out an x, 2x plus 7. This starts with a minus, so I start with a minus, and I can factor out a 3. Okay, so this one factors into 2x plus 7 and x minus 3. Beautiful. On the bottom of that first fraction, 2x plus 7 is not factorable. Those are both prime numbers. There's no greatest common factor. All right, ooh, let's make a squiggle here so we're not confused. There we go. Ooh, a binomial on the top of the second fraction. Can I factor anything out? Yeah, I see a greatest common factor of 5. Now the last one, the one on the bottom, does not have a greatest common factor, but it happens to have a 1 in front of the x squared, so we can actually kind of skip this crazy process we had to do with the AC method. Now, if you don't remember this little trick, do the AC method, you'll still get the answer. It'll just take you a little bit longer. I want to find two numbers that add up to positive 4 and multiply to negative 21. That would be, whoops, negative 3 and positive 7. Okay, now that it is all completely factored, let's start crossing things off. On the first fraction alone, I see this 2x plus 7. It's going right away. Great. I see one other thing, and that's the x minus 3. And that's it. Wow, okay, so the whole first fraction went bye-bye. Very nice. I'm multiplying straight across. And that's my answer. Okay, beautiful, beautiful. We got these first two multiplication problems. Not too bad. Well, all we did is we multiplied. Of course we did. What I meant to say is all we did is we factored, and we did the same thing as in simplifying. So we just canceled some stuff out. We just had a bunch more stuff to cancel out. Alrighty. Let's continue. Even with my stuttering, I think I'm not going to redo this video because I already got halfway through it, you know? I know. Okay. So here we have a division problem. What's awesome about these, this is actually a multiplication problem. Let me show you why. The first step to every single division of rational expressions, the first step is always rewrite it as a multiplication problem by flipping the second fraction and making it multiplication. I meant to make that a bigger dot and that didn't work. There we go. Okay. Now we can do all the factoring and pretty much everything we did for these problems. So dividing is just multiplying with an extra step. All right, let's get to factoring. Ooh, okay, so this binomial right here, this is actually x squared plus 0x minus 81. It's just a bit silly to write the 0x there, and I guess here I am being silly, but I wanted to make sure you saw that it's there, we just don't write it. So for that top portion, I'm thinking of two numbers that multiply to negative 81 and add up to 0, which is positive and negative 9. Let's take a look at the bottom. X squared minus x minus 72. So two numbers that multiply to negative 72 and add up to negative 1. That would be negative 9 and positive 8. And I scrolled too far downwards. There we go. Second fraction, can't factor the top. There's no GCF. And there's no GCF on the bottom either. So, let's get to canceling. All right. The first fraction, easiest thing to spot, I think, would be the x minus 9s. The next thing that jumps into my eyes are the x plus 8s. That's it. Okay, so what are we left with? X plus 9, and let me give myself some more space, over x minus 2. Okay, there it is. Boom. Okay, let's do one more division problem. Well, I guess, and that will be it for this video. All right, so division problem. We're always going to start off with rewriting it as a multiplication problem. And I think you should do this before you start factoring. The reason being, it's the easiest way to avoid making a mistake. Okay. Can't tell you how many times I've had students factor first and then accidentally cancel things before flipping. And then they get it wrong. And it's sad. All right, so we have a multiplication problem, which means let's begin factoring. just like in that last one, we have x squared plus 0x minus 1. We just don't write that 0x in, which means this top part, two numbers that add up to 0 and multiply to -1 would be positive and -1. 12x is a monomial. We can't factor monomials. 3x is also a monomial, so there it is. For the bottom of the second fraction, two numbers that multiply to give us -8, and when we add them, we get +7. That would be +8 and -1. Sweet. Let's begin reducing. The x minus 1s jump out at me right away. But then I'm kind of in an impasse. X plus 1 and x plus 8 don't cancel. All I have left is the 3x and the 12x. Now, in the previous video, I mentioned that if we're going to cancel something, it has to be all or nothing. And that applies to binomials and larger, more than one term. When we have monomials, so something with one term, like the 3x and the 12x, we can cancel bits and pieces because it is not connected to anything with addition or subtraction symbols. So, keeping that in mind, one thing I can reduce here is our x's. If there's an x on the top, x on the bottom, I cross one of each out. In this case, they're gone. I can also reduce my 3/12. Why? Well, 3/12 is the same thing as 1/4. So let's make the 3 into a 1, the 12 into a 4. And that's about it. Let's multiply straight across. Oh, need to get myself some more room. There we go. X plus 1 times 1. Sure, you can write the x, the one out in front. I will do that for now, but you really don't have to. So it's kind of silly writing the 1 out front, so I'm going to go ahead and delete that. But I wanted to make sure you saw that I am multiplying x plus 1 by that 1 on top. Okay, and that is our final answer. I hope this was helpful to those of you who watched it. Please feel free to ask me questions or your teachers questions. We'll be happy to, whoops, I zoomed out too far. Oh no. Well, we'll be happy to answer any of the questions that you have. Fractions are tough. When we put some variables into those fractions, it gets even more tough. Yep. Okay, well, have a wonderful rest of whatever day it is for you. Be well. Bye.